All right, so we got a little more triggy trig to do here, children. We got Channing Tatum. I don't know if you know him. He's in 21 Jump Street and a few other wonderful films. He's doing a roof job and needs to properly set his ladder to access the roof. You know, there is a right and wrong way to set a ladder up against a house or a structure of some kind to make sure it doesn't slide out. His 20-foot ladder needs to make a 75-degree angle with the ground. All right, so his ladder extends 20 feet. How high up can his ladder reach? How far from the base of the house should his ladder be set? And then if he used the angle it makes with the wall, would that change anything? Okay, so let's think about all these. We got a lot going on, but first, let's go ahead and draw a really awesome picture. So he's got a structure, and he's got a ladder reaching up, right? And this is a 20-foot ladder. And then we got our ground. Whee! And the angle that it makes, we said, is going to be 75. Okay. And for all intents and purposes, let's say this building is built correctly and is plumb with the ground, therefore, or that is plumb, so it makes a right angle with the ground. Alrighty. That's what we say when we're talking about like vertically level, if you will. That means plumb. It's a different word. Level's horizontal, plumb is vertical. Awesome. America. Alrighty. So we want to know how high up his ladder will reach. So what we're talking about here is this length. We'll call that X. And then the other one says how far away from the base, how far away from the base of the house should his ladder be set. That would be that length, right? So we're going to figure some information out here and see what we can do to help Mr. Tatum here out in this situation. So let's go for it. First, let's solve for our height. Well, I've got a right triangle with an angle of 75. With reference to that angle of 75 degrees, where is X? That X is opposite. Okay, so this is going to be our opposite side. And we know this is our hypotenuse. Get hyped about that. Well, what's opposite and hypotenuse? What trig function am I going to use for that? Woo! Sine of 75 degrees, my angle, is equal to the opposite side divided by the hypotenuse. So I can go ahead and solve this bad boy. I'm going to need to multiply by 20 on each side. So I'm going to have 20 times the sine of 75. All right. So when I type that all in my handy-dandy TI-83 or 84 calculator, or whatever calculator you might be using, we should be using one of those, I'm going to get X is approximately equal to 19.3185, blah, 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 19.3 feet. So that's how far up it's going to reach. So maybe there's a situation where it's like, oh, is the 20-foot ladder going to get the job done? You need to get up to the second floor. We might be cutting it a little bit close if you're talking like 10 foot of floor. So always good to know and calculate this based on what size ladder you should be picking up, right? If you got to get to the third floor, you're going to want something over a 30-foot ladder to make sure you can get up there. Wonderful. Okay, next, we want to know how far away he should have it placed. Well, we got a couple ways of going about this at this point. We know our height of the ladder is going to be 19.3 feet. We could use Pythagorean theorem, but I am going to keep getting tricky with it because I don't like using values that I've just figured out and I have rounded, because then my answer becomes less and less accurate. So if I start using 19.3 over here as my opposite side, this is going to be off a little bit as well. And over time, that can really make a big difference. So I like to use as much of the given information as I can to keep things accurate. So let's do that. Plus, we can get more practice with the trig. Okay, so Y, with reference to the 75-degree angle, this guy is my adjacent side, right? Okay, so that would be cosine. We got adjacent, we got hypotenuse. So cosine of my angle is equal to my adjacent, y, over 20. And if I solve this, I'm going to multiply by 20. Oops. And I got to plug that in my handy-dandy calculator. So I've got 20 times the cosine of 75. Looks like this guy's going to be sitting about 5.1763, so 5.2 feet away from the building. That's where the bottom of the ladder is going to be. So you can use a tape measure rather than having to look at using a a special level or even like the app on his phone to get the degree, you could just set it a little over 5 feet away from the building and you should be pretty solid. Okay, that answers the first two questions. Now, if we use the angle it makes with the wall, would that change anything? Let's think about what that means. Well, what angle does it make with the wall? We know that 180 degrees in a triangle, right? We know there's 180 degrees in there. So minus 90, minus 75, that's going to leave me with 15 degrees. So if I'm using that angle to figure out my values, does anything change? That's really what we're asking there. And the idea is that we're getting into, well, what do we know about these two? They add up to 90, right? 75 and 15. Start talking about complementary angles and our sine and cosine tangent of those complementary angles. What happens when we start using that complementary angle in there? Does it change something? What happens? So let's take a look. Let me see if I can make this all, yes, smaller. Okay, so we got 15 degrees up there. If I use that as my angle, and I want to solve for one of these guys. Let's say I want to solve for the y. Y, rather than being my adjacent side, if I'm looking at it from the 15-degree angle, it's my opposite side. So if I want to solve for y, let's see here, we'll make that blue again. Well, opposite and hypotenuse would be sine of 15 equals my opposite over my hypotenuse. And if I plug this in my calculator, after multiplying by 20, going through my normal algebraic steps, I'm going to get y equals approximately 5.2, the exact same answer. Samesies would go for x, except for now, remember, x is my adjacent side. Whoop. It's next to the 15, not across from the 15. So I'd be using cosine of 15 equals x over 20. And if I were to multiply by 20, solve this thing like I've done before, when I plug this in, and I would highly suggest plugging these in your calculator so you can see it firsthand, I'm getting about, we should make that a squiggly equal since we're rounding, make sure people know that. We don't want Channing Tatum to think these things are exact and then he gets upset. You don't want that. All right, I end up getting 19.3 when I plug that in. So there are multiple ways of setting these up. These trig functions are quite interesting, in fact. So the general idea is the sine of an angle, sine of an angle is equal to the cosine of the complement of that angle. That's more of just like an interesting math thing that we can observe, not necessarily 100% needed in construction, but it's something we might observe over time. We don't even realize it, and we're using that just in the context of a problem, but it's kind of interesting to point out. Well, interesting to me at least. I hope it's interesting to you because, America. Alrighty. Alright, so Mr. Allen's new dock, my new dock, is quite the high step up. Okay, we built it high for the floods that we get on the river. So I decided to build a temporary ramp out of scrap wood that I got lying around from the dock build. Eventually we'll be building a super cool deck that connects everything down there. It's going to be awesome, super cool and rad. Hopefully, actually, by the time you guys watch this, it's done because I'm recording this end of August. So we'll see. We'll check back in. Alrighty, the dock is 2.5 feet off the ground, and I have enough material to make a 6-foot long ramp. Alright, so like the surface that we walk on. What angle of incline will the ramp be at? It's important. Is this going to be way too steep to like walk up comfortably? Let's see here. So my dock, looks like something like, I got some posts, right? And then got the platform that runs across. There's my new dock. Whee! Alright, okay. And it keeps going. Anyways, we want to build a ramp that comes down. Actually, let's make it like this. Okay? And that thing's we want to figure out what kind of angle will that make with the ground, right? Well, that's a great question there. What kind of angle are we going to get? I said that this is going to be, 6 feet? And we said that this length was 2.5 feet. I want to figure out this angle, oftentimes notated as theta. That little circle, O with the line through, the curly-coo line. This sounds like we're going to need to get tricky with it. I'm pretty sure. Ooh. So from this angle, what side is this? That's my opposite side, OPP. Yeah, you know me. And then this guy's my hypotenuse, because it's across from the right angle. Know what I'm saying? Because that dock is perfectly plumb, so it forms a right angle with the ground. Alrighty. Opposite, hypotenuse, which one uses that? Sine. And how do I find the angles? I'm going to use sine inverse. So my opposite side is 2.5. My hypotenuse is 6. Let's plug that in. Oh yeah. So we got to get our sine inverse of this bad boy. Now, if you get different angle measures than what I have, double check you're in the right mode, or ask me in class. Sometimes your mode of your calculator gets switched and you start getting really jacked up numbers and you're like, what is going on here? Why am I not getting this? You are in the wrong mode. So come check with me. I forgot to put those as squigglies. Squiggly equals, because we're estimating, right? We're going to round, not estimating, we're rounding. I'm going to get 24.624 blah 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 degrees. I round to 24.6. I'm thinking that's a pretty comfortable ramp. I mean, it's a little steep. Definitely not handicap accessible, which I believe needs to be closer to like 8 degrees or maybe even 10 degrees at most, but depends on the county. So this will be all right for us for now before we build that dock. Jenny's going to love it. She likes running up there. She can jump up there now, but she likes ramps too. It's kind of nice. So, bibbidi bop. There we go. We figured out what angle it would be. America. Freedom. Rock and roll.